Hello everyone and welcome to Fleming's Math. This video covers simplifying radicals using perfect squares. We're going to use the list of perfect squares at the top to help us solve these problems. Let's look at question number 1. We have the square root of 8v squared. 8 can be simplified or broken down into two numbers. 8 is 4 times 2. And then we still have the v squared. Now, the square root of 4, as you know, the square root of 4 is 2 because 2 times 2 is 4. So we're going to use that to simplify this. This is the square root of 4, which is 2, so the 2 comes out of the radical. This 2 is going to stay in the radical. And then the square root of v squared is just v. And the way that works with the variables, you might remember, is just take the exponent and divide it by 2. So 2 divided by 2 is 1, so that's going to be v to the first power. Now, what stays in the radical is the 2 here. So the answer is going to be 2v times the square root of 2 for our final answer. Now let's pause and let's just review some of the perfect squares that we have at the top. We started with square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16, and so on. And let's skip to this one. The square root of 144 is 12 because 12 times 12 is 144. We will be referring to several of these as we go throughout these problems. Let's look at number 2. The square root of 100 n squared. Well, the square root of 100 is actually 10. So 10 is going to come out. And that's because 10 times 10 is 100. And then for the variable, that's n squared, we'll just divide the 2 by 2. 2 divided by 2 is 1, so that means n to the first power comes out, and our answer is 10n. Number 3, square root of 16v. Well, the square root of 16 is 4, because 4 times 4 is 16. And then the v, that's just the square root of v, is going to stay in the radical. So our answer is 4 square root of v. Number 4, we have the square root of 50r, square root of 50r. Now 50 is not a perfect square, but we can break down the 50 using 25 times 2. So square root of 50r is square root of 25 times 2, and then times r. Now, the square root of 25, that's a perfect square. The square root of 25 is 5, so 5 comes out because 5 times 5 is 25. And then the 2 and the r will remain under the radical. So our answer there is 5 square root of 2r. Number 5, we have the square root of 80 n squared. Now 80 is not a perfect square, but 80 can be split into 16 times 5. So we have the square root of 16 times 5 times n squared. Now the square root of 16 is 4, because 4 times 4 is 16. So the 4 comes out. Also, this is an exponent of 2, and we divide that by 2, so 2 divided by 2 is 1, so that means n to the first comes out as well. The only thing that's left inside is the 5. So our answer is 4n square root of 5. Okay. Number 6, square root of 75x squared. 75 is not a perfect square, but we can split that up into 25 times 3. 25 times 3 is 75. And then times the x squared. 25 is a perfect square. The square root of 25 is 5 because 5 times 5 is 25. The 3 is going to stay under the radical. The square root of x squared is x. So we have 5x with the square root of 3. All right. Number 7. We have the square root of 18n. 18 is not a perfect square in itself, but 18 is 9 times 2. So now we have the square root of 9 times 2 times n. What is the square root of 9? That is 3, because 3 times 3 is 9. So a 3 comes out. The 2 is going to stay in, and the n also stays in. So our answer is 3 times the square root of 2n. Number 8. Square root of 64p. Well, 64 happens to be a perfect square. The square root of 64 is 8, because 8 times 8 is 64. So 8 comes out, but the p is going to stay in. So our answer is 8 square root of p. Number 9, square root of 125k. 125 is not a perfect square, but 125 is 25 times 5. So we can rewrite this as 25 times 5 times k. 25 is a perfect square. The square root of 25 is 5, because 5 times 5 is 25. This 5 will stay under the radical, and the k stays under the radical. So our answer is 5 times the square root of 5k. And then the last question, number 10. Square root of 27v. 27 is not a perfect square, but 27 can be written as 9 times 3. So we have square root of 9 times 3 times v. The square root of 9. 9 is a perfect square. The square root of 9 is 3, because 3 times 3 is 9. And then the other 3 and the v will stay under the radical. And so our answer is 3 times the square root of 3v.